welcome to the mathematics in my channel. Today we are going to solve another beautiful integral from 0 to infinity 1 over 1 plus x raised to the 5. We know 5 is a golden ratio. Raised to the 5 dx is equal to, the answer is 1 minus 1 over golden ratio factorial over golden ratio factorial. Well, how to begin? Well, first I'm going to take our integral. This integral is equal to I, and we can use a substitution. So if we take x raised to the 5, x raised to the 5 is equal to tan square of theta, then we can isolate the x. So x is equal to we know tan raised to the 2 over 5 of theta, and now we can differentiate. So dx is equal to now 2 over pi tan raised to the 2 over pi minus 1 of theta. Now according to chain rule, derivative of tan we know secant square of theta d theta. Okay, now we can plug in here to our integral. So we know I is equal to, now we should change the limit, lower limit and upper limit. Lower boundary we know when x approaches to 0, theta also approaches to 0. When x approaches to infinity, we know theta approaches to pi over 2, and here 1 over, now 1 plus x raised to the 5. X raised to the 5 we know tan square of theta, and 1 plus tan square of theta we know secant square of theta. So secant square of theta raised to the 5. Here dx, we know dx is equal to 2 over pi tan raised to the 2 over pi minus 1 of theta secant square of theta d theta. Okay, then we can write this is equal to integral from 0 to pi over 2, and here 2 over pi we know constant, so we can write outside of the integral sign. And here now tan raised to the 2 over pi minus 1 of theta over, here we can write secant to the 2 times pi of theta, and here secant square of theta. So we can simplify. We know secant raised to the 2 over pi, here 2, so minus 2 of theta d theta. Okay, then I'm going to write tan and cos by using sin and cos. So we can write 2 over pi integral from 0 to pi over 2. Then now we know tan is equal to sin over cos. So we know sin raised to the 2 over pi minus 1 of theta over cosine raised to the 2 over pi minus 1 of theta, and this secant theta we can write in the numerator, and we know cosine raised to the 2 pi minus 2 pi minus 2 of theta d theta. Well, now we can simplify. So here 2 over pi 0 to pi over 2. Now here we have sin raised to the 2 over pi minus 1 of theta, and here cosine raised to the, here we have 2 times pi, here 2 over pi, so minus 2 over pi, here minus 2, so here minus 1 we know plus 1, so minus 2 plus 1 we know minus 1 of theta d theta. Well, now interesting point, we know now we can use beta function. So we know the definition of beta function. Beta of mn is equal to 2 times integral from 0 to pi over 2 sine raised to the 2m minus 1 of theta times cosine raised to the 2n minus 1 of theta d theta. Now we can find m and n. So now we can write 2 over pi minus 1 is equal to power of sine 2m minus 1. Now minus 1 get cancelled, 2 also get cancelled, and m is equal to 1 over golden ratio. And also we can find the n. So we know 2n minus 1 is equal to 2 times golden ratio minus 2 over golden ratio minus 1. Now minus 1 get cancelled, 2 also get cancelled, and we have n is equal to pi minus 1 over 5. Okay, now here we can write our integral is equal to 2 over pi times, now here we know we can write 1 over 2 beta of 1 over golden ratio comma golden ratio minus 1 over golden ratio. Okay, now these 2 get cancelled, and we can write 1 over pi times, now we know beta function, we can write beta of mn is equal to, we know this formula, gamma of n over gamma of m plus n. So we can write here now gamma of 1 over golden ratio times gamma of golden ratio minus 1 over golden ratio over gamma of 1 over pi plus pi minus 1 over 5. Okay, now we can simplify. So we can write now here 1 over pi, here gamma of 1 over pi times here gamma of pi minus 1 over 5. So we know this property about golden ratio, pi minus 1 over 5 is equal to 1. So if you want, you can simplify here. Now we can write this part gamma of 5 minus 1 over 5, we know 1, so gamma of 1, we know gamma of 1 also equal to 1. So in the numerator we have only gamma of 1 over 5, and in the denominator we have here we know this part get cancelled, so gamma of pi. And also we know about this formula, x times gamma of x is equal to gamma of x plus 1. So now we can write this is equal to gamma of 1 over pi over, now pi times gamma of pi, so gamma of pi plus 1. Okay, now we can write this is equal to, we know 1 over pi minus 1 factorial over here, this is equal to pi factorial. Okay, this is the answer. And if you like this video, please subscribe this channel. Thank you for watching.